Y'all are already stuck on number 1. I'm a little worried about you guys.
I didn't do the notes.
Well, even if you hadn't done the notes, this is not something so much that you would need for the notes.
Just show me it once.
Okay, so let me show you what they're meaning for you to do.
Oh gosh, it's up there low.
Yes, it's up there, okay, because I'm going to record it. All right, so they say express the ratio. First of all, they've got this picture, but you don't even need to look at it. They are basically basing this picture off the Parthenon, and they said its architects used the numbers 81, 16, and 36 in determining its dimensions. So they want you to express the ratio 81 to 36 in decimal form. All you're doing is dividing it out, guys. 81 divided by 36, what is that as a decimal? It is not rocket science. 2.25, okay?
Oh, so you just divide.
You're just dividing.
Oh, wow.
Okay? Yeah, that's why I'm like, tell me you're not stuck already.
It just looks more complicated than
Guess what happens on number 2 when you divide it out?
You do the same thing.
You get the same number.
Can I borrow your calculator?
No, I'm using it.
Yeah.
I do have this one.
Oh, yeah, I just need a little.
You can use that one.
just kidding.
Okay.
The little one.
Now, 3 is probably confusing. That one I could understand you going, what? I'm not so sure about 1 and 2. Huh?
Are you just doing cross multiplication?
Yeah, kind of. The extremes, if you're, I thought I put this in the video, but if you don't remember, the extremes are like if you're kind of looking at the ratios as you're going down this way and then you come into the top and you're going down this way, the extremes are the outside numbers. So they would be like 81 and 16. So when we multiply 81 times 16, which would be like cross multiplication, Charlotte noticed, 81 times 16 is 1296. Now, if you cross multiply the other way, 36 times 36, what do you get?
You get the same thing.
You get the same thing. So they're telling you that when you're doing, they're trying to show you that in proportions, when you cross multiply, they're equal, okay? And they say it this way. The product of the extremes is equal to the product of the means. Mean, normally in math, means average, kind of in the middle. So the 36s, the two 36s there, they're in the middle. You won't hear that notation anywhere but this book. You'll see it in other books, but they're not going to use it in the instructions much.
So 36 is the means, and 81 and 16 are the extremes.
Extremes, So when you hear that in language, that's what they're talking about. And again, Charlotte noticed they're cross multiplying and showing that the two parts are equal. Well, if you read 3, it says, show that in this proportion, the product of the means is equal to the product of the extremes. You're just showing this right here. You're showing that if you cross multiply, it's equal.
Okay.
So that's all you were doing on number 3. They ask you, what is the number 36 called with respect to 81 and 16? What did I tell y'all, those two 36s? They were in the middle. They were called the means, okay? So, again, that's just some vocabulary that, honestly, you probably won't use outside of this book, okay? Number 5 says, write the proportion that follows by taking the square root of each side. So you got 81 over 16 is 36 over 16.
It's 81 over 36.
Okay, so what they want you to do is to square root both sides.
I think it's 81 over 36.
Oh, I see. Oh, sorry, thanks. That's what you meant. Okay, I thought you were telling me the answer a while ago. Okay. So if you square root each side, what would you get on the left side?
9 and 6.
Uh-huh.
And then 6 and 4.
Okay. Do you think that result is going to be equal? Just curious. That's probably what they're going to ask you next.
Can you go farther down with 6 and 4?
You could reduce if you wanted to, and it doesn't matter. Let's just not reduce, because if you notice, is the product of the means still equal to the product of the extremes? Can we still cross multiply?
Yeah.
Yes. 6 times 6 is 36, and 9 times 4 is 36. So if we square root each side, we're still getting an equal stuff when we cross multiply. So they're kind of trying to tell you here that that you can, like when you're solving proportions, you can write them, you can cross multiply to solve them, and then even if you were to square root each side for some reason, if you needed to, you could still cross multiply and solve them. You can treat this like an equation. I could have here, like some of you guys asked, I could have reduced 9 over 6. Doesn't that reduce to 3 halves? What is 6 over 4 reduced to? 3 halves. You can see they're equal if you just reduce the fraction, can't you? Okay, so they're just trying to sell you this idea that when you're solving proportions, you can cross multiply. It says express each of the ratios of your proportion in decimal form. So like on number 6, what they're wanting you to do, they ask you to square root both sides, and you had 9 over 6 on one side, and you had 6 over 4 on the other. And if you divide those out, you get 1.5 on both sides. They're just, again, trying to show you proportions are great ways to solve equations, and a proportion is two fractions that are equal. Okay, and we can build them to help us solve problems. They want you now start solving using proportions, and they tell you there's an exact replica of the Parthenon in Nashville, Tennessee. Has anybody ever seen it? I've seen it on videos or something, just different videos or movies. It was on Jackson. Okay, so okay, so we got this rectangle again, and it's still 81, 36, 6, or the proportions, but the deal about it is they went ahead, if you multiply, what are they doing here with the 228? They're putting 228 here. Oh, okay, so it's an exact replica, but replica doesn't mean they didn't make it 81 feet long. They made it 228 feet long. Maybe they needed it to be bigger. I think they use it for concert venues or something. So they labeled the width and the height, and they want you to solve. They give you this proportion based on that figure. 228 over the width is equal to 81 over 36. They say solve this proportion to find the width. They set this up for you. So what are you going to do to solve it? Cross multiply, right? We could cross multiply here. We could say 81 times W is 81W, and 228 times 36, let's do that on the calculator, is 8208. So if I divide both sides by 81, isn't that what I would do to solve now? Okay, so let me do it in a different color just so you can see that was a different step. I divide by 81. You get the width is equal to, I'm getting 101 and a third. Yeah. In 0.333, a third. How many of you have your graphing calculators right now?
I have mine, but it's dead.
It's dead. But they're actually wanting you to see, if you want to solve a proportion to find the height in feet, you could say, okay, you could put 81 over 36 like they did on the right-hand side. I'll just write it on the right-hand side. Look back up at number 7. Didn't they do this? They took one side and divided another side by it. They want you to find the height. If you follow along with what they're doing there, you know that you've got, never mind. No, we're not going to skip it. We're going to do it a different way. When we divided that out a while ago, what did we get for 7? What was the width?
101.3.
Okay, 101.3. That was, and we had, let me put it as 101 and a third, just so we have it exact, which that was like 304 over 3, right? Mm-hmm. If I took that and divided by that original, that was the amount I got as my new width. Let's divide it out by 36 and see what we get. So let's put 304 divided by 3 in the calculator. and you should get the 101.33333 that we had earlier, and you divide by 36, you get the scale factor. The scale factor here is 2.814814. It's basically 2.814 repeating if you divide in your calculator. I want to show you, let's play around with this a little bit. This was your width that you found in the earlier problem, number 7, and this was the original width, right? Our scale factor here, if I divide these out, I'll get the scale factor. Didn't they multiply 36 by about 2.814 repeating to get this new width up here? Let me see if I can show you something else and see if you get it. Look at the side that's labeled 228 and 81 in your book. Let's divide 228 by 81. The scale version of it is 228 feet. The original was 81. Let's take 228 and divide by 81. Guess what we get?
2.814.
We get 2.814 repeating again. Okay? So if I want to find the height, if you look at the box in your book, just in case you're not looking, height is 16, right? If I want to find the new height, what could I do? What would I multiply by to find the new height?
Height times width.
Well, there's a scale factor going on. They did not explain this but in the picture, but the black numbers are like some original numbers. And the red numbers is they're blowing this up proportionally.
Oh.
Okay? They didn't explain that at all, and they're being very confusing about the way they do it, which is one of the reasons the book, sometimes I'm just like, oh, well, I don't know why they did that. But if I started off with 16, how am I going to find my new height if they're blowing it up by the same number every time? Notice both times, didn't we get this 2.814?
Well, yeah, multiply by the scale factor.
Yeah, if I take 16 and I multiply it by that scale, we keep finding the scale factor here. Found it again. So what I'm going to do is multiply 16 by 2.814, and I'm going to get the new height. That would be the easiest way to do it. I don't quite understand why they're doing what they're doing here. But I can find it. It's 45.024. When I blow something up, it's always by a scale factor. It can be a whole number, but here, was it a whole number? No, it was just 2.814 repeating.
Because you're blowing it up like it's on the ground.
That number that's circled up there in blue, huh?
Because you know how you have like the distances between does he mean like blowing up like on a graph?
Like just enlarging it, like when you're working on Word and you paste the photo in and you want to make it fit and you drag it and it pulls all the sides, yeah, just like a dilation. It's pulling all the sides proportionally. That's not how they're explaining it in the book, but this is what's going on, and I think it's the easier way to understand it. They're doing some funky proportions here, but I'm just going to explain it to you this way, okay? So they're basically taking the original and they're blowing it up by a scale factor of 2.814. So if I want to find the new height, all I have to do is multiply this old height, 16, by 2.814. How did I find the 2.814? Just checking.
You divided 28 by 8.
Yeah, they told me the new length was 228. The old length was 81. I divided those out, and that's how I got 2.814. And then on the we solved for the width using their proportion. They gave us, but we could have done the same thing here. We could have said the width was 36. And let me multiply it by 2.814, and I would have gotten the same thing that they got, which was that 101 1/3. So all they've done is taken each side and multiply it by 2.814, and they kind of explained it strangely.
Wait, can you go with that?
Sure.